So a recursive function, really, or a sequence, we're looking at sequences and numbers, and when you think of sequence, you're thinking about something coming in order. So if I name the sequence, the oldest sequence in the world that you guys know is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... Okay? That particular sequence goes on forever. A recursive sequence is one that looks in the past and does something to something that happened before and makes a change. Okay? So here, we're looking at this definition. A recursive formula or a recursive definition for a sequence is a set of statements that A, indicates the first term or the first few terms of the sequence, and B, tells how the next term is calculated from the previous term or terms. Okay? So let's look at an example here so that you guys can see exactly what I'm talking about. Here in this particular definition, we are given the term L1 of 113. That's the very first term we're starting with. And then notice it says L sub n equals the previous term plus 41 for any integer starting at 2 and above. Okay? So generate the first 4 terms of the sequence is this. So basically, if I look at this, I'm going to say n on this side, if I make a little table, and then I'm going to put L of n over here, okay? I'm going to say at 1, what was the first term that they gave us? Yep, 113. That's the very first thing. Sequence 2 was adding 41 to the last term. So that is how they got 154. Sequence 3 is adding 41 to 154. That's how they got 195. And then 4 was 236. So I want to double check if this is indeed right. So what I'm going to do is take out my handy dandy calculator. I'm going to show you guys how to do this. I'm going to add a calculator page to this. And the first thing I'm going to do, I'm actually going to put in the number 113 and just hit enter. Okay? The next thing I'm going to do is I'm going to go to control, click on control, and then go down to this little negative sign. Right above that negative sign there it says ANS, answer. Okay, so once you hit answer, the ANS button, you're going to say plus, right? And what was the number I was supposed to add to each one? 41. And then I'll hit return. Guess what I do every time I hit return now? Dun, dun, dun. There it is. So I can check it really fast. Pretty easy, huh? So your inspires are actually set up to to think recursively if you type it in that way. Okay? Sweet. So here we have another example, 1B. You guys get to try it on your own, on your CASs, and see if it works. I want you to see if you can make your CAS to do the same thing. Okay, so try that now. Okay, so if I'm going to start over and do the same thing for this example, it's 97, enter, right? And then I'm going to go to control, answer, right there. And I'm going to say minus 23 this time, enter. So my next one's 74, that's correct on our page. Then it goes down to 51, yep, check. 28, check. 5, check. Negative 18, check. Negative 41, check. So, going back to our sheet here, it does indeed work. Okay, so this is verified. We verified it. So, big old check. Okay.
So you're just minusing 23.
You're subtracting 23 from the last term every time.
I was not highlighting here, so
Yeah.
like, is that basically just like
So for in the last example, sequence is described by using the symbol L, and the symbol L sub n denotes the term in denotes term number n. So when we're looking at sequence, we're going to say the first one in the sequence, the second one in the sequence, the third one in the sequence, and so on. So it's just telling you if it has L sub 3, that means it's the third one in the sequence, okay? Also, quite frequently, I see it in terms of A and A sub n, okay? So whenever you see A, more frequently in dealing with recursive sequences, it's usually an A, to be honest with you, okay? I don't know why our book uses L. The term that precedes the number n is the term n minus 1. So, and the term that follows n is the term that is n plus 1. So if you think about it, we're at n. The one before it was n minus 1. The one after it is n plus 1. Does that make sense to you guys? Okay. So the symbol, big L with a little n minus 1, can be used in place of the words last, and you could say previous term. So whenever you see that big L with the n minus 1, the sub n sub minus 1, that means the last term. Okay? Excuse me. So on this one, if you notice, L sub 1 equals 113, and then it says L sub n, the next one, you could think of it like this. Next equals last plus 41. Right? And this is another way of writing it the same way, but they're going for, instead of using n minus 1, they're using n plus 1. Okay? All right. So a recursive definition always includes at least 2 lines. One or more lines define the initial value of the sequence, and the other line defines the relationship between consecutive terms. So let's look at example 2a. If you guys turn your page. Notice that they're using the capital A now on this one. We start with 10,000. And notice it's going down to 9,600, 9,200, and so on, of dollar amounts left on a car loan of 400 is repaid each month.
Wait, what is that? Say up there.
Okay, so in other words, we're taking a $10,000 loan and we're taking 400 away from it each time as we pay it back, right? So if I want to write a recursive definition, A sub n, I'm first going to say A sub 1 because that's my starting value. And what would that be in this case? 10,000. So that's the first thing I'm going to write. Okay. My next one would be A sub n. Okay. And I'm always going to take the last one and subtract what from it again? 400. So I'm going to write A sub n minus 1 because that's the math way of saying last, and subtract 400. That make sense? Okay. I want you guys to try 2b by yourself. Okay? Try that real quick. My first one, B sub 1. Should be 850. I hope that's what you guys have. Okay? And then B sub n is B sub n minus 1. And I think it's going down by 75 each time. Is that what you guys got?
Yep.
Okay.
What is the end? What is the end?
That means the next. So this is like saying next equals last minus 75. Okay? All right. So now that we've got that, we're going to get into some word story problems that is more likely to be realistic. The NCAA women's, yes.
Do you have to do the
All right. So NCAA women's basketball tournament originally consists of 64 teams which are paired up in single elimination contests. At the end of each round of play, the number of teams proceeding to the next round is half the previous number. The sequence 64, 32, 16, 8, 4, 2 gives the number of teams in the tournament at the beginning of round N. Use words to write a recursive definition for the sequence. So what I would say is I'm starting with what number? 64. Okay? And then I would say the next term is half of the last term. Okay? So now it says write a recursive formula for the sequence. So if I say a sub 1, what should a sub 1 be? 64. Good job. How about a sub n? A sub n minus 1. And then what am I doing to that though? Dividing. Yeah, this one's a divide. So either I can have a line underneath it and say divided by 2. The other way I could write it is say 1/2 times a sub n minus 1. You could do that too. Okay? All right. This is the last example of the day. This one is a sequence. C is 324, 108, 36, 12, and 4. Take a second to see if you can write the sentence down and try to get the recursive value yourself. Okay? Hopefully this is what you guys got. It's C sub n equals 1/3 times C sub n minus 1.
I just wrote